Okay, let's look at our last group of stack questions here. The first thing that we're asked to do is to convert this expression from infix to postfix without resorting to running things in our algorithm that we have. So let's look at that. 10 plus 3 times 5 divided by 16 minus 4. Now maybe the first thing to notice about this is that we got to be very careful with our precedence of operations. And to notice that we're going to have to do the multiplication here, 3 times 5, then divide by 16 minus 4 before we ever get to the plus. So it might help to just maybe rewrite this in terms of its fully parenthesized expression. So 10 plus, and then we would put a parentheses there, 3 times 5 divided by 16 minus 4 would give us a pretty good idea of the order that we should do these things in. Okay, so the thing to remember when we're converting from infix to postfix is that the order of the operands doesn't change. It's the order of the operators that is going to change. So when we write this out, we're going to write 10, 3, 5. Okay, so here's our first right paren, right? So we want to actually compute that 3 times 5. Then 16 minus 4, so 16, 4 minus, and then we do the division, and then we do the addition. So 10, 3, 5 times divide, 6, 4 minus, divide, plus. Okay, so that is an answer to that question. And there we have it. Okay, so here we're simply asked to evaluate this expression. So when we're evaluating an expression in postfix, we are going to make use of the stack. So let's get rid of this. All right, and let's make our stack here. So we're going to put 17 on the stack, then we're going to put 10 on the stack, and then we come to our first operator, so we're going to add 10 and 17. So we pop 10 off, we pop 17 off, and that gives us a stack of 27. So we'll just cross that out, make a new stack, now we have 27. And then we add 3 on the stack, because that's our next operand, but then we get to a multiplication symbol. So 3 times 27. So 3 times 7 is 21, 3 times 2 is 6, and 2 is 8, so that gives us a value of 81. So our next stack would have 81. Then we push 9 on the stack and we do the division. 81 divided by 9. So remember, we gotta remember the order. It's 81 divided by 9, not 9 divided by 81. 81 divided by 9 is going to give us a value of 9. And that will be our final value. So let's plug that in and check. All right. So the final thing is now to go back to this modification here to our postfix, our infix to postfix function. And we want to modify it so that we can correctly do something that has exponentiation in it. So the only change that we really have to make here is we just have to look at this precedence table. And we have to notice that exponentiation is a binary operation, but it's a higher precedence than everything else. So this is actually going to be a one-line change. We can put in our higher precedence for exponentiation. Okay, so we can go back down here and let's just use copy and paste. And we'll go back up here and we'll put in this test case. So print infix to postfix. All right, and remember we have to have this fully parenthesized. So we need to make sure that, well, let's see, I think that has enough parentheses there. Let's just see. Oh, I was missing a space there, huh? And I'm missing a final parentheses. Blah. I needed a space there too. There we go. Much better. All right, so 5, 3, 4, 2. So notice that everything is still in the right order. So we do the subtraction first, which we would need to do. So 4 minus 2 is 2. So we're going to do the exponentiation. So 3 squared is 9, and then we'll do the multiplication last, which is just in the order that it should be. Okay, so paste in the answer. So we can do that. Paste in the answer. Check me, and there we go, we're all correct.